Are you designing PCBs and would you like to create your own professional enclosure for it? In this video, we'll take a detailed look at how to create a custom enclosure using SolidWorks. And if you don't have SolidWorks already, you can get SolidWorks Maker for $15 a month and follow along in this tutorial as well. I have a walkthrough on how to install it. If you want to see how, just see the link below. And if you have any questions or issues along the way while you watch this video, place a comment and I'll follow up in any way I can. So let's walk through the design process on how to design a metal enclosure for this PCB. On the PCB, we see that there's some barrel jacks on either side and also a USB-C connector. We want to make a housing that safely protects the PCB while allowing the user to access the connectors on the outside. And for some applications, you might choose to have a metal enclosure for shielding reasons. So unfortunately, there's no mounting holes in this PCB, although that's okay because we'll use the edge of the PCB itself for aligning it in the enclosure. And we would like to assemble the enclosure with screws. So the first thing to do is to check that the reference planes and the origins are in the optimal place. It's pretty close here, but I usually prefer to have the origin on the bottom side and in the middle of the PCB. So to fix that, we just add a new top plane we'll use in our assembly. Simply select the bottom of the surface of the PCB here and add a reference geometry plane. The next thing to do is to add this to a new assembly where we can draw up our housing. So to do that, just go up here and click Make New Assembly from Part. And just drop it in by just clicking Enter. And we can see now that if you click Control 7, it's kind of oriented in a weird way. We wanted it to kind of lay on the top plane. So to fix that, just right click here and click Float. And then we'll just click our right plane and we'll make that with a front plane, like so. We'll take our top plane that we created before and make that to our top plane. And then we'll take the top plane here and make that with our right plane. So now if you click Control 7, which gives you an isometric view, it's looking okay. So that's how we want it. So now let's get started on actually drawing our enclosure master model. If you go up here and click New Part, we'll draw the part on the top plane here. So just click Top. And then you can see now it jumped into part editing mode, which means like when this is blue and the rest of the assembly is transparent, you are editing in the model context. So to start up, let's just draw a box shape and figure out what should our enclosure size be. And we see that it's something like 65. You can change the orientation by just clicking spacebar and then clicking on the box. So this seems about right because it kind of follows the connectors. Let's start with that. And then let's try to make it 50 in width because then we have space for screws on the sides. And you see that the sketch is now blue. That means that it's not fully defined. And if you try to drag any part of the blue, you find out what's wrong. You see this is kind of, it can float around and we want it to be in the middle. So let's just click one line and then we click the middle origin. You can either click here or you can go up here and click origin. Just hold down Control and then click coincide. Or actually you can click midpoint because then it like takes the middle of this line and places that in origin, which is what we want. That's it. And then go up in features, click extrude. And now we're kind of creating our first box. So here we can choose the height and also the height going the other way. Or you can choose a midplane. In this case, we don't have the origin right in the middle of where we want it, so we'll just choose a distance going up first, such as, let's say, we could probably get away with something like 8, although let's do 9 just to give us a bit of space. And let's see on the bottom, 2 would be too little. 4, that looks about right. So let's see, that would be 13 all up. So let's make it 6 so that we have 15. But actually, let's do 10 and 5. Then we have a 15 millimeter high box, but it's kind of, you have good space on top and good space on the bottom of the PCB. There. And now I'll just add a bit of shape to the box. So I'll just add some fillets in the corners. Like this. I'll add some chamfers for the top and bottom. And this looks all right. I'll also just add some small fillets there. Like this. And now when we go up here and have a look, you can kind of look through the model in this way. And so you can kind of see would this work. And I think for this case it would work. The connectors are coming out to the surface and we don't have any kind of conflicts. So we'll go back here, and then now we want to do a shell feature, because this model we've created is now actually solid. So we want it to be a hollow box. So go up here in shell, and let's say 1.5. We want to make this in aluminium. So 1 is usually kind of getting thin when you are doing CNC machining. 1.5 is comfortable. So let's choose that. And now when we go up here and have a look, you can see now it's hollow. So that's good. That's how we want it. Now let's try to do some cutouts for the connectors. So here it can be hard to see. You can go up here and click Hidden Lines Visible. Then go up here and click Circle. So we want a cutout for this circular geometry here. There's multiple ways of doing it. You can actually use the existing geometry, like we have a circle already there. If you click on that when it highlights and click Convert Geometry, you see that it creates a new circle for you. Sometimes these models from the PCB can be like converted in weird ways, where it actually draws a curve here, like it draws a spline. When you hover over it, you can see what type it is. It draws a spline which is joined there, and that can create some issues later on. So we don't want to do that. We'll just draw a standard circle here. So here, just when you hover over it, you can kind of sometimes find the center. In this case, it doesn't really want to, and that's probably related to the fact that it was trying to do a spline, so it doesn't register that this is actually a circle. So when you want to try to find out where is the center of this circle, you can just draw some like geometry to help you. So up here you can click line or center line, and you can click for construction. This creates some sketch that is not used to actually make features, but it can help you in defining positions and so on. So here it's caught onto the edge of this circle on this side and the edge of this circle on this side. And now we can use the center of that to define where our center of the circle is. Just like this. And I want some sort of clearance to this connector here. So let's just have a look here first. We can make a guess at the size of the connector just by dragging it over, so it's probably going to be 5. And now I'll change this to a construction geometry. So this is not actually the geometry we're going to use to actually do the cut, but this is defining where the connector edges, and we can use this now to do an offset. So this will create another sketch which is offset from this, and we can use that to kind of give ourselves some room or head space. And 0.1 is usually a good place to start. That gives you a bit of space for the connector to come through if there's any tolerance issues with the CNC and all that. So we click OK. And now this looks all right. Now we have one on the other side, and to me it looks like they are symmetrically patterned on both sides, so we can use that to our advantage. If you just click a line here in the center, double click to exit the sketch. Then you can click on this circle and just go up here and mirror, and then mirror about line. So now created the same circle on the other side, and in fact it does look like it's perfectly mirrored, so that's good for us. Now let's look at the USB here. This is a shape which is box with fillets on the corner. It's not actually an oval, but even though it looks like it. So let's try to catch the shape of connector here by clicking select loop. Click again. So now you can see it actually caught the geometry of the connector itself there. Let's get this and use it to draw up something we can use. Now this actually looks rather alright. It's like lines and curves that we could actually use, although it's split here. So let's put these as construction geometry, because we don't want to use those. And to select the loop of this that we don't want to use either on the inside, you can right click and click select chain. And when these are construction geometry, it should automatically select just that. Otherwise it would select the whole chain. And over here we can click for construction. So now this gave us, if you click chain again, it gives us kind of the connector outline, but there's a point missing. If you zoom in here, you can see it's open here. So let's just draw a line to connect them. And now we can select the chain again, and let's do a offset entity. And let's offset it by 0.1, just like the other connectors. So there we have a cutout for the USB now that's 0.1 offset from the actual connector. And let me just Control Z for this for a second, because what it did there was it didn't convert this to construction geometry, so we had 2 lines. And let me just show you what I mean here. So let's click offset entities, and here you can choose construction geometry and select base geometry. And what it'll do is it'll change automatically this internal set of lines to construction geometry, because we didn't want to use this for the cut, we want to use the offset. So click OK. And now you see these lines here, they're just construction, and we just have one solid line which is offset by 1.1 millimeter, which is what we want. And that's this side done. And now we can do the cut. Just one tip, I actually just realized that I was drawing in the assembly context. So make sure that when you do this sketch that you are within the part context. So it has to be blue here. And you can also see if you go back here that it's hard to see now, but the other parts in the assembly would be transparent if you could see them. So we continue on just selecting the sketch and then click extrude cut. And here, to see what's going on again, let's go here. Now it just chooses a blind by default, but what we want to do is just cut up to the next wall, so to speak. So in here you see we have a thickness of 1.5 as we defined before in our shell feature. And if you just go up here and click up to next, it'll automatically go up until it meets the next surface, which is ideal for us now. So we'll click OK to that. And going back to look how it is, we can also go back to the assembly context. So this looks pretty good. So we also have connectors on the other side that we want to cut out holes for. But since they are the same position as these forward connectors here, we could actually reuse our sketch instead of having to draw up a whole new sketch. So you can just select the sketch here and then click extrude cut. In this case we will choose from this plane, so this surface here, and we'll just change the direction of the cut. And we want to select the inner wall. In this view it doesn't allow us, and it can't do a section cut while we are in here. So I'll just click OK to that, and then I'll do a section cut. And then I'll go back into my feature we're working on. And now in here, I'll select up to surface, and I'll click the inner surface there. And that creates a nice clean cut that doesn't interfere with anything else. But you see now we also got the USB, which we didn't want. So I'll show you how to just get those. So in here in selected contours, by default it selects the whole sketch because it assumes that's what you want to cut. but we can select we just want to cut this one and this one. And just make sure that it actually selects out to the full line and not just for this construction geometry line. And this looks all right to us. And you can also see in the preview how it would want to cut it. So that looks good. So there we go. That's the holes cut for the connectors. Now that we have our kind of basic enclosure shape made and also the holes through it, we'll just go ahead and save the assembly and the part before we proceed any further. So here I've gone ahead and saved the assembly first, and here we have a part which was created internally in the assembly. So this is called a virtual part now. It's not saved in its own part file yet, but we want to change that. So here just rename it first, and we'll call it Enclosure Master, because this will actually be our top level part, but next we will split it up into two parts, at upper and a bottom. So we'll just use this this model as our kind of reference, and to save it as a model of its own, just click Save Part in External and click OK. And now you see it changed, and now it's actually saved as a part. You might see that it's not like made it to anything here, and that's because sometimes it won't do a what's called in-place mate, which is kind of controlling the model. So you can control it in different ways, like you just click here and click Fixed, and that would fix it. Or you can try to just mate it as it would be. So you can click right-click the top plane with the front plane, and the right plane with the right plane. If it disappears on your right mouse button, you can just go Assembly and Mate. Click OK. Click front and top. Mate. So now when this little dash disappeared, it means it's fully defined. So it's fixed in the assembly. Before we proceed to split this part into a top and a bottom part, let's talk about the screws. So we wanted to assemble it with 4 screws, let's say. And that's why we created some geometry out here on the sides. So let's see how we could do that. If you go in here and click Edit Part again, and we'll choose the front plane here as our sketch plane. And let's draw a rectangle here. So this just defines the 4 corners where we would want the screws to be. And let's say 45 by 45. Let's see how that looks. And let's just align this box with the center origin here. If you see that when you're trying to do like a mid constraint to this, and it doesn't come up like this, it's because it's actually selecting the origin from the assembly. So you can just go up here and then find your part and just hold down Control while you click origin, and then you can put your constraint there. Now I'll just select chain, because we want this whole chain to be in construction geometry. That for some reason changed it to blue. Oh, that was just a glitch. Okay, so let's have a look at creating some material for our screws to kind of sit within. So I just draw 4 circles, and that's kind of like the material that I would need for the screws. And we'll just select all of them to be equal. So you just select them one by one while holding down Control, and then click equal over here. And that creates a constraint that says that they all have to be the same size. So now if you drag one, you see that they move like this. And if you look through and see the edge of the PCB, you can see at this point it would be a problem. Any bigger than this, it would hit the PCB. So we don't want that. We want something like this. And let's see what we can get away with here. 5.5. So For M3, this gets a little small. Maybe we could get away with a M2.5, something like that. But what I would do here is probably like go for 7 or something like that. And I would probably go out to 50, no, let's say 47 instead. And you see now that, of course, that wouldn't really work. Our screw would be here and stuff. So now we can make adjustments to the housing instead. We made an initial guess, but we found out that we need some more material. And there's no real issue with making the housing wider. It would make it very slightly more expensive, but that's okay. So go in here and edit, and we'll click our master, or like our first boss extrude. Let's just increase this to 55. Let's have a look at that. So that looks all right now. So we'll choose 55 as a width for the case. And now let's go back into our part where we made our sketch. And now we can go up into features, click extrude, and then click up to next. And then direction 2, up to next. So this looks a little bit weird to me. Let's see. So this was just a preview that was looking weird. I'm not sure why that was, but actually it does extrude up until it finds the next material. So you can see how it like draws a weird yellow shape there. That's not actually what it's going to do. I'll show you. Click OK. And you can see now it actually drew up a material up to the edge, or up to the next surface, which was what we wanted. Now looking at this, let's do a section cut. That would be fairly hard to machine this corner here for CNC machine. So instead of doing perfect circles like this, let's go back and just add some straight surfaces instead. So just hover into the sketch and click a line, hover the mouse over it until you get these 4 diamonds. That means that now it's trying to draw a tangent line. We can click up until this line here. Let's just put it out like this. And I'll just do another tangent. Click OK. And then rotate like this, and we'll just select this line here. Click Convert Entities. And that just created the line from the wall there. So that if we go and change the geometry of the housing again, it'll follow, this line will follow the geometry, which is what we want. And now let's trim away the excess. We don't want that, we don't want that, and this. And we'll select this to be vertical. And now this is defined. Now you can see if you right click and select chain. Oh, it actually missed, let's see, it does have, oh yeah, so we need to trim this away as well. It can be hard to see sometimes, but it actually had like a line behind it. So there, now it's a enclosed shape. Now instead of drawing this up 4 times, what you can do is just delete these other ones. And then we create some center lines. Run the center. Make sure that they're defined fully, so that they need to be like not able to move like this. So just select it and go up here and click Origin, Mid. Because we'll use this line to mirror the feature, and if it was like very slightly off like this, it would mirror in the wrong way. It would mirror like not symmetrically. So yeah, always make sure that it's your center lines are fully defined like this. So now we can just right click this and click Mirror Entities, and then click Mirror About over here, and that creates the same feature over there. And just do the same here, and while holding down Control, you can do this again and click Mirror around this. So that saves a bit of time of drawing up sometimes. Now when we close the sketch, we can see that the extrusions are as we would want them. They come up to a nice flat surface on either side. But now we have a sharp corner, so let's just add some fillets in here. We'll just add 2mm radius fillets so that we can use a 4mm drill. That means that the parts can be machined fairly quickly and would reduce the cost. Okay, now let's have a closer look at the part. We'll just open up the part itself. So we would want this part to be split into two, and looking at the holes we have here, because they're round, the parts would have to mate right in the middle of these holes. And luckily we have a PCB where the connectors are like more or less the same place. So we can create our parting line going through the center of the connectors. So to do that, we will draw a line which you can imagine kind of like cuts through the part and splits it into two. So we'll select the plane, the right plane here, and I just want to look at the other side because there we have the USB connector. So I'm just turning around and using spacebar to orient. And then we want this split line to go through the middle of the circles here, so that when you put the parts together, it doesn't interfere with the connector. So let's just hover over the hole here until you get this, and you can start from the center and drag out. And SolidWorks will kind of follow you, and you just select here and go over to this side here. So now you see you get like a completely defined line because it knows it has to be touching the center of the circle and also the edges here. And now we have the USB in the middle here, and imagine you're dragging the parts away from each other. So we have a little bit of geometry that goes in, and because we have a like clearance of 0.1, that wouldn't cause an issue. But I would anyway just like make a straight wall here, and we can touch that up later. So now we have our split line. You can go up in Insert, Features, and then Split. And then it's already selected the drawing now. You just click Cut Part. Now you can see you get a split part, so you have a top and a bottom now. And just select them here. And we'll just go ahead and save the parts by just double clicking on these and giving them names, clicking OK, and it should look like this now. And then once we click OK, it'll open the parts that is just created, and it'll just ask you, do you want to use the same units from your original part, and you just click yes. And now you see it all disappeared, and that's because this feature here, it has like consume cut bodies. You can just disable that. And now this has become our kind of master part. We won't need this anymore. We'll continue working in the individual parts. So we'll just save that and close this for now. And we'll save each of these parts that it opens as well. Now we'll just go back to our assembly here, and we'll just suppress this. And then we'll just insert the top and bottom components. So if you have the parts open in the background already, if you just go up here and click Insert Components, you'll find them right here. And if they're not here, you just browse for them. So we'll just place them wherever. And we'll take the bottom first. So just looking at our PCB, it has to be aligned like this. This is top plane and this is front plane. We'll make them coincide, and then the right plane with this right plane. And then we have a top plane, no sorry, front plane with this top plane. So there we go. And then because they are from the same master part, you should be able to do like this. Just merge the two, or like make the two origins, and it'll snap to this. So here we have our assembly with our top enclosure and our bottom enclosure now. And let's have a look inside. So this is looking right. We need some screws though. So let's go into the bottom here. And let's go up in Features and then Hole Visit. And now we'll just go in here and just click on the surface. This is where we kind of want to drill our holes. And we'll go back here and we'll select what kind of screw or hole we want to make. And in this case, I'll use a kind of a socket head screw. So that's a DIN 912. And we'll try to use this is a small case, so we'll just use M2.5 and go back to our positions here. And now we want it to be in the center of this geometry that we made here. There. There. So now you see it equates like a hole for the screw to go into. And actually I want the screw to be kind of more hidden into the part, and that's why we created this material here. So we can add a head clearance, let's say 3 millimeters enough. And now it looks like this. Now I'll just, these are quite sharp kind of edges here, so I'll just round them off by adding a little fillet here. Doesn't have to be much, even just 0.2. This should be able to be machined with a round tip drill in the CNC, just to kind of remove any sharp edges. So like this. And now on the other side we need to add the thread. So we'll proceed to open the top enclosure here. And in here we want the thread to kind of start on the surface. So I'll go up and click hole wizard. And then in here we can select the thread here. And we selected a 2.5 M2.5 screw, so we'll select M2.5 there. And now we'll just place them in the middle here. Hover over the edges here and it'll find the center for you. There we go. And it was by default selected through all, but I don't want the thread to go through all the way because it'll be visible then. So we'll just select blind, and it's usually a good idea to do at least 2 times the diameter in thread. So we need 5, and let's see if we can get away with that here. So yeah, it doesn't have to hold much weight, so let's try to just reduce that a bit, because we have a trade-off that is we don't want it to pierce through the material. So let's see how this looks. So this looks all right. And now let's have a look at the parts and see if we need to optimize anything. So the first thing I notice is that we have some quite sharp kind of edges around here, which are hard to machine. So let's just round that off with some fillets. And we'll just select 2 millimeter radius fillets around here. And let's see how that looks. Looks better. And then let's do that up here as well. And now that'll select the rest there. So now we just kind of rounded off that whole edge, and that's fine. I think that's much better, easy to machine. And let's do that on the other side as well. Two millimeter. There we go. Now let's try to bring some screws into the assembly just to check that the thread and head size that we've chosen will actually fit a standard size screw. So if you don't have screws, you can maybe get them through Toolbox or online. So I'll just select a M2 times 6, let's try that. So it's M2.5 times 6. And I'll just make the screw in the hole here, and then the head on the surface there. And we can see that it sits quite nicely. So for this, no adjustment is needed. We can use a M2.5 times 6. And if in real life, if the thread is not screwed in or like all the way as we specified here, we can just use some washers to bring out the screw a little bit. So I'll just repeat this and add it in the 4 corners. So now that we have the screws in and all the other done, let's just have a look at how the PCB is actually supported. So At the moment, it's just resting on these kind of surfaces where we also had a 0.1 millimeter clearance. So let's instead try to support the PCB in like 4 kind of corners in here, just so that it rests on the housing and not on directly on the connectors there. So to do this, let's just hide the top here, and you can just hover your mouse over what part you want to hide and click tab. That hides the part there. So we'll change the transparency of this one, and then we'll just go and edit this part. Change top view. And then we'll draw a sketch here for our 4 corners we want to support on. So something like this. So I'll change this to construction line. And this should be 39 and let's say 25. And let's just get this in the center now. Select line, click origin and midpoint. So now we have the 4 corners we want to support it in. Let's make some geometry for that. So I'm just imagining like kind of 4 pillars in a way. And I want them to be the same size. So I'll just select these sides here that I want the same length, and I'll click make equal. And the same for the other direction. Make equal. And I'm imagining that we should extrude this up, and then we have like a little cut in where the PCB will sit in. So for that reason, I'll just add a little bit here. We'll do 39.2, because then we can have the middle of this be 0.1 from the edge of the board. And I'll show that in a second here. Let's just give these some dimensions. 3 millimeters enough. And 5 is fine. And instead of having sharp corners, let's just round this off. 1 millimeter. And it's like breaking the sketch there, but that's fine. Sorry for the noise. Okay, and now let's extrude this up. So we need to get to the bottom of the PCB there. So, and I can't select that through here. So I'll just click OK now, and I'll just do a section view, just so that I can get to it. And we go back into this feature. So we want to have this come up and meet the PCB. So we'll say up to surface there, and click OK. And I just held down Shift to select this. So if it doesn't select it like this, you can also hold down Shift and select. That kind of forces SolidWorks to select the outermost geometry that you're looking at. So now we have these little pillars come up, but we also want some side support. So let's try to do that. So here we'll just let's go back there. So to create a new sketch on this surface, you just click on there and click sketch. So this creates a new sketch on the same surface of all these 4 posts here. So I'll just click the surfaces, hold down Control, and then convert entities, and that creates the outline there. So we don't have to draw it up again. And then we will just add a line here in the middle. And I'll do the same for all 4. So maybe now you're seeing kind of where I'm going with this, that I created the post initially to support the board, but then the middle of this is kind of to support the side. So that was why I added 0.1 on either side, so that we have a little bit of clearance for the PCB there. And I'll just trim this away. Oop. As soon as I trim it away, you can see that it loses the reference. That's okay, we'll fix that. And that's just because it was referencing the middle of the sketch line, but now actually we'll reference the middle of this instead, like the geometry, instead of the line that it copied. there, and then we will extrude this with minimum the PCB thickness. So let's just say 2, because why not? And then we'll just add a little chamfer here. Let's say 0.5, just so that the PCB falls down into it quite nicely. There, and then we'll just add a fillet in the bottom here, 2mm. That's fine. Okay, click OK. So now when you place the PCB into the bottom housing here, it's supported by this post here, so it doesn't actually touch the connectors, which is ideal because we don't want to put load on the connectors themselves. We also want to constrain the PCB from sliding back and forth in this direction, and there's nothing really stopping it right now except for when it kind of hits the connectors here as well. But let's try to constrain that. So we'll go in here and edit part, and we'll click sketch on the bottom here, and let's create just normal rectangle. We'll just like create little bumpers like this that comes up and meets the PCB, and we'll just create some center lines around the middle. This is just so that we don't have to draw it in all the 4 corners. We can just simply mirror it. And I'm just fixing it to the origin here, the center lines. There. And now I just dragged it up to the PCB, but if we did that, we might have interference due to tolerances of the PCB and the CNC. So we'll just give it a little bit of clearance as well. And we can see that nominally is 30, so we'll take 30.1, and that should be enough. And then we'll say this should be 3mm, probably enough. Let's say the center of this should be a distance from the center here, 18 maybe. Yeah, that looks fine. Like this. So we just select the chain, and then we can mirror it about this. And we do the same. Then hold down Control, select chain, and mirror around there. So there we have four corners there. And then we just extrude. And we need to extrude up to minimum where the board is. Let's just, to make it easy to machine, we can just go all the way up to here so that it meets this surface up here. And let's round off this so it could actually be machined with a 2mm. And that seems to be okay. So it's adding 2mm fillets so that the drill can actually come in and machine this. And instead of having these sharp corners as well, let's just add a 1mm fillet. Like this. And then we just let's see if we can add a little fillet here as well. Let's add 2 so that it's consistent around the bottom. So 2mm fillet. The bottom here as well. Yeah, that looks pretty good. And we'll see that how that looks like without lines. So now we can see that we have the board constrained in this direction and also in this direction. And in the up and down direction, it's supported by the connectors here. So by these surfaces, by the connectors. And that's okay for this application. If you really wanted to, you could also make posts like this in the roof on the top enclosure, and then have them come down and meet there. In this case, that would result in the top lid having to be like larger, like the box dimensions, if you look here, if we made tabs that come down and touch the board there, the overall shape of this part will be enlarged. So it's a trade-off, and in this case we won't bother with that. So we just have the supports in the bottom here and forward and back. Now let's proceed to how we will actually have this made. So we'll try to have it made at JLCPCB. They do CNC machining as well, and they just need the step files, and then they also need a technical drawing if there's any specifics. And specifics include also threaded holes. So in this case we'll need a drawing for the top part at least. So let's try to make a drawing for this part. To make a drawing, just go up in new file here. When you have this one open, you can make a drawing from part. And it'll ask you which kind of drawing template you want to use. If you're just starting out, you probably don't have one, so you can just use a standard one. And just drag in from the right here. And we are more interested in the other view. So here where we can actually see the holes we want to drill. Here we can just do another projected view, because it'll be good to see the depth of the threads. So actually, instead of doing this, let's just do a section view. So up here in section view, you can click cutting line there, and we can select the middle of the hole. Now you can actually see inside the part the depth of the thread. So that helps sometimes to communicate what exactly is the dimension of the thread here. So it's 4 deep, and see the hole size like this, and then sometimes I just put 1 decimal so it's not confusing, if it doesn't have to be exactly like that. And then we want some just basic dimensions. So really, JLCPCB, they just need to know which kind of thread it is, so you don't have to put too much like information on the drawing. You can if you want, but it's not really needed for them to actually produce it. But I'll just put the dimensions for where the holes are, and then also say that the part is symmetric. So by putting a center line in the middle here, you're kind of communicating that this part is actually symmetric on either side. So any dimension you put on one side, it applies to the other side as well. So put center lines in both directions. And then you can use this hole callout. Just select there. It'll automatically get the type of hole from the hole wizard. And so in this case, it's registered that it's a M2.5. We have it 4 places, and it should be a 4mm depth. And this is pretty much it. Like, you can add lots of other stuff, materials and stuff like that, but for this case, we'll just keep it simple. So we'll go ahead and save this, and then also save it as PDF. So we'll also save the other parts as step files so that we can include them in our JLCPCB quotation. So you just go up in File and click Save As, and then you save a copy. And then you just click down here and click Step AP214 and just click Save. So we now have our step files of both the top and bottom enclosure. And then we also have our drawing just for the top enclosure. And you'll notice we didn't create a drawing for the bottom, and that's because usually suppliers like JLCPCB, they'll just get all the dimensions from the actual step file. And so if there's nothing specific, then there's no need for a drawing, and it'll save you a bit of time. So obviously you don't have to use JLCPCB. I'm not sponsored or anything, but they do have good prices, and it's pretty easy to use. So let's try to just show this as an example. If you go to jlcpcb.com and you go into CNC machining, then you can choose obviously 3D printing. It'll also work with these files for 3D printing, but we want a metal enclosure. So we'll just drag this file in. And after a little bit of time, you'll notice that it's loaded the files in. So you have a little preview here, and you can just check that everything looks fine, because this is the file that they'll use for actually machining. And sometimes maybe you get the files confused or something and you upload the wrong one, so it's good to just double check that this is actually what you want to have machined. And yeah, here you can choose the material. We'll just go for aluminium. And you can choose a tougher grade or just standard grade, and it'll affect the price, obviously. Here you can choose surface finish. So I like to use bead blasting. You can also have a conductive anodizing if you want for EMI shielding, stuff like that. Or you can just have standard anodizing. So let's say you want like a black anodized house, and you can choose between glossy or matte. And the roughness is basically how smooth they'll machine your part, and it affects the price as well. A higher value means a finer surface. A rougher value means they can machine the parts quicker, and therefore it's a bit cheaper. And you'll see that it asks for threads as well. And this one is the bottom one, so it doesn't have threads. And let's go back and just choose the bead blasting here. Bead blasting unknown. Actually, also a good combination here with bead blasting is to choose bead blasting and then a clear or like a natural anodizing, because then you get this like kind of matte surface finish that looks, or like a satin finish that looks really nice, but then you also get a protection, like a corrosion protection, which is clear, so it still looks like satin aluminium, which is quite nice. The normal bead blasting, it's really fine kind of little ridges on the surface, and they scratch up fairly easily. But if you anodize it, it kind of hardens that and protects it against scratching. So next one here, let's just choose the same. Anodizing, natural. And in this one we do have threads. So you see here that it asks you for drawing. So we'll just upload the drawing here that we just created before. And you can see that it accepts the drawing now. There's also something here called subassembly, and I'm not entirely sure what it is, but I imagine that it's they're just checking that the parts fit together when they actually produce it. And in this case we can use it because we are actually making parts that need to fit together. So we'll say yes, and it has to fit with this part. And then they also ask you for product description. So you can just click a aluminium enclosure, and that's just for the customs. And then that's pretty much it. So you just choose your build time for whatever price you're happy with and time, and then proceed to order. So that's it. Thank you so much for watching. I hope you found this video interesting and that it'll help you in some way to create your own metal enclosure for your PCBs. If you have any issues along the way, feel free to reach out. I'll help you any way I can, and I'm also available to help as a mentor. And if you found this helpful, please subscribe to my channel. I have many interesting projects in the pipeline, and I'd love to have you with me on the journey. My name is Raz. See you later.